This is the river crossing assessment. In this situation, we have a river that is 1,104 meters wide. It has a current of 7 meters per second. And our boat, which we're going to drive by pointing directly across the river, has a speed of 24 meters per second. The question is, at what speed and angle relative to straight across does the boat look like it's traveling to an observer on the shore? So what we want to do here is we have two vectors. We have the water vector, and we also have the boat vector. And we always align vectors tip to tail. This boat one is 24 meters per second, and our water vector is 7 meters per second. And we want to know what the combined vector is going to be. So we can find this side with Pythagorean theorem, 7 squared plus 7 plus 24 squared, and then the square root of that whole thing equals 25. Which gives us this side. So that's the speed. And then the angle of that is going to be the, this is the opposite angle. And then this is the hypotenuse. So the one that relates opposite and hypotenuse is sine. So we'll do the inverse sine of opposite 24 over hypotenuse 25, which gives us an angle of 73 degrees. 73.7 degrees. So that's this angle right here. So that's great. The next question is, how far downstream are we going to land on the opposite side? In order to find this, we know that the total horizontal distance is the length of the width of the river, right? 1,104. And we know at least our speed in that direction is 24. So if we divide this by 24, we'll get 46 seconds, because this is meters per second and this is meters. So it's going to take 46 seconds to get across, and we're going 7 downshore per second. So 7 times 46 gives us 322 meters downshore. Next question is, what angle would you have to point the boat so you could land directly across? So for this, I'm going to erase some of this so we have room. So the next question we have is, what angle relative to straight across do we need to point the boat in order to go straight across the river? Because we know that our current is kind of pushing the boat. So even if we point the boat straight across, the current's pushing the boat this way. And so we end up going like this. So we want to point the boat kind of out a little bit so that we end up just going straight. So our boat, we're pointing it out some angle. We don't know what that angle is. That's what we're trying to find out. And then our current is constant as a 7, which makes our combined vector end up being straight across. So we want to find this blue vector is a 7. We want to find the theta. So we need to relate these two sides. We have a 7 and a 24. The 7's opposite of our theta, and the 24 is the hypotenuse. So we're going to use sine to relate the two. and we'll do sine of 7 over 24 will give us a theta of just about 17 degrees. So theta equals 17 degrees. That's the angle the boat has to travel relative to straight across, so the boat goes straight across. Next question is, how long is it going to take to go straight across? Because now our direction, the speed we're going straight across is less than 24 because it's a side of this. So in order to get the red value, the red magnitude, we're going to use Pythagorean's theorem. Do 24 squared minus 7 squared. Do the square root of that. And we're going to get 23 meters per second. The width of our river is 1,100